Welcome to the show, Tony Mann. This is Scholars in Spotlight, and we are recording this podcast in kind of a hot weather in the middle of a heat wave, and we are sitting in the middle of the buildings. So, Tony, thank you so much for doing it. I mean, I know that we were planning it, and finally it happened. Thank you.
It's a pleasure. Yeah.
Brilliant. So, I think our conversation started about a book you have been working on. So I think the best introduction would be that if you can introduce a little bit about your own background and then how you come towards the writing this book.
Right. Well, I'm a mathematician. I've been working in the mathematics department at Greenwich for the last 30 years now. And I have a strong interest in the history of mathematics. I've been heavily involved in the past with the British Society for the History of Mathematics. And this book is a book about the mathematical history of Greenwich. It's edited with contributions from a number of very well-known historians. The editors are myself, Raymond Flood, who is retired from the University of Oxford, Mary Crokin, who used to work in the National Maritime Museum in Greenwich. And it covers the history of mathematics at Greenwich from 1675 to today.
Brilliant. So how long have you been working on this book, if you would like to share?
Longer than I like to admit, really. It started with a conference we had at the Maritime Museum, which Mary organised 15 years or so ago. And sometime after that, we had the idea that it would be good to put together a book drawing on that conference, but also filling in the gaps with accounts of things that weren't covered in that conference. So we've been working on it for some years, with contributions, as I've said, from various eminent historians, and we're now in the final stages before publication.
Brilliant. I mean, I have actually looked at the book. I've read few of the chapters, and this is not at all a book which seems like about complex mathematical theories, although I don't mind that book at all. But this is actually based on different stories, contribution, discoveries, and I really enjoyed reading it. I was not expecting that, so thank you actually for to be honest. Yeah, this is math books are most of the people who are not mathematicians a bit hesitant for picking up, but this is a very different approach to the book.
Yes, well, I mean, this is more about history and people than about maths. There's a little bit of maths in it, and many readers will know some of the mathematics, but it's really about the people, the politics, the history, how maths came to be done at Greenwich, what kind of maths is done at Greenwich, what kind of people did it.
Brilliant. So we'll come back to the book just now, but I would love to know a little bit more about what kind of research or what kind of work or what kind of teaching are you doing in Greenwich? Or how do you define yourself?
Okay, most of my research has been in the history of mathematics. I've worked for a time on 17th century mathematics, which I like because the maths of that period isn't too difficult, although it does get quite challenging when Newton comes along. And then, for complicated reasons, I got drawn into looking at mathematics in Scotland in the 19th century for a book that was being published on that topic. And since then, I've been looking at really the maths at Greenwich over that whole period of 350 years.
Wow. Okay. So you mentioned math is not that complicated. Do you mean the history of mathematics gets a bit blurry after some time?
Well, I think there's a problem if you're writing history of modern pure mathematics, because most modern pure mathematics is so abstract that there's only a few people in the world who understand it, and it takes years of work, and that's not what historians do. Historians of that mathematics wouldn't be in a good position to write about it because they haven't been involved in understanding it, and the people who do understand it are too close to the story, so they wouldn't be able to write its history. So I think there's a problem when the mathematics is hard, because to write good history you have to understand what you're writing about. That's why I'm interested in the early modern period, which is when modern mathematics like calculus was suddenly being developed by Newton and Leibniz and people like that. And so you get very bright people working with mathematics, which is just about understandable.
Yes.
And that makes it a lot of fun because you can see how ideas with which you're familiar, like calculus, how people struggled to actually come to these ideas, and you realise actually how difficult this could have been. We think it's easy because we do it in school, but it wasn't easy for the people who discovered it.
This is a very interesting one. I don't think that I would have heard about this kind of dilemma which is going on maybe at present. Although when you're referring it to something abstract, are we talking about what string theory calculations are going on or around these kind of things?
All sorts of things like that. I mean, topology, string theory, group theory, the Poincare conjecture, Fermat's last theorem. I mean, Fermat's last theorem is very widely known. Andrew Wiles proved it in the 1990s. How many people have read and understood his proof? Certainly under 100, I'd have thought. I could be wrong. And that's a particularly well-known, widely popular piece of mathematics. For some mathematics now, when people prove a result, nobody is going to check it because it's not worth anybody's time investing in. And there are examples at the moment of mathematical proofs which the community isn't quite sure whether to accept or not, because those people who are qualified to judge aren't going to waste 2 years of their research time looking at somebody else's work.
True. Is that one of the reasons maybe that the modern stories are not really that well defined, and that is why what we are hearing in public is just the account of either individuals who are who are mathematicians or some astronomers who are working on their very specific project, but the story in itself, like what you have written some of it in the book, is not there, I guess. Is that why?
In terms of modern mathematics, I think that is a real problem. I mean, Graham Farmello recently wrote a book about the history of string theory. It's a brilliant book, but he doesn't explain the string theory. Or at least, I mean, he covers a bit of it, but you end up really having to take on trust what he says is very interesting mathematics. And that is a real problem, I think, for historians of contemporary mathematics. It isn't such a problem for the Greenwich book, because the mathematics there isn't so difficult and it's easy to describe the context.
Perfect. So in the book, what are the most important, or what are the most well, I don't want to use the word important just because I think everything is important to everyone, so I don't want to force that, but anything you think is actually prominent discoveries which you have mentioned. I mean, either you want to list it, or what are your favorite ones? I mean, if you put it like that.
Well, I think I might start off by giving an account of the subject matter of the book. A lot of the history of mathematics at Greenwich is based around the Royal Observatory. It was set up in 1675. I'll come back to that in a moment. And for a considerable period of time, it was really the centre of English mathematics. It was where the most advanced mathematics of the day was being done when it was set up. And the Astronomers Royal, starting with John Flamsteed, were major figures in the mathematical world. So the observatory is a large part of the story. There's also the Royal Naval College, which came to Greenwich in 1873 and which employed a number of famous mathematicians over the next 100 years. There was also the Royal Hospital School, an educational establishment, and in the book we make the point a lot of the mathematicians who worked at Greenwich were not just research mathematicians, but they were also heavily engaged in teaching and in mathematical education. And now, of course, we have the University of Greenwich, which moved here in 1999, and which has its own advanced mathematical research, some of which, coincidentally, is in the same tradition as a lot of the work done at Greenwich before that.
Brilliant. So, how many things are associated with Greenwich? I mean, we hear about it, but when I was reading it, I realized, wow, okay, so there's Cutty Sark, there's observatory, and then there's also the meridian. But you mentioned one of the chapters is why one of the reasons that our mathematics department is really prestigious and works on quite a lot of advanced problem. There's a history behind it. I mean, would you like to?
Yes, I mean, the mathematics department, the University of Greenwich was previously Woolwich Polytechnic and then Thames Polytechnic, and in the 1990s, 1980s, it was based at Woolwich, and Mark Cross joined as head of department, and he had a particular interest in numerical mathematics, and at that point, he introduced Britain's first mathematics and computing degree, which made computing an essential part of the mathematics curriculum. And he also built up a research group working on numerical mathematics, using computers to do mathematics and making sure they get the right answers. And that work, in fact, is very much in the tradition of what was happening at Greenwich, really back to 1675, and certainly with the 18th century astronomer royal Neville Maskelyne. And that work has included in the university mathematical modelling of the Cutty Sark, the ship, how best to preserve her, how best to prop her up in dry dock, work which led to the recent refurbishment and the way she is now displayed, and which has ensured she will survive for the foreseeable future. The Cutty Sark, of course, was the fastest ship in the world in the 19th century, and she is in Greenwich as a tourist attraction, showing what ships of that time were like.
Brilliant. So, what chapter or what part of the book would you like to now dive deep into? Because I want to know a lot of things. Right. And do you want to continue with the observatory?
I think let's start with the story of the observatory.
Okay.
So it was set up in 1675. Why was it set up? Well, King Charles II had a French mistress, and she told him that one of her friends in France had devised a mathematical method for calculating the position of a ship at sea, calculating specifically its longitude, using the position of the moon. And since navigation was critically important to Britain at the time, and since finding longitude was a major problem, Charles was concerned that the French would solve the problem first, and therefore he gave money to set up an observatory specifically to solve the problem of finding a ship's longitude at sea. It was done on the cheap. The king only gave £500, so it had to be on land already publicly owned or owned by the king. It had to be away from the centre of London, which was very smoky, on a hill, as it was built in Greenwich Park on the foundations of a previous building to save money. It was built by Christopher Wren and Robin Hooke, two of the great scientists of the time, for a cost of £520, and it was built and opened in 1675.
Brilliant. So, how far was the centre? How far the population was actually? Is there any number that how far did they build? I'm sure
Yes.
that please.
I don't know, actually. There was the City of London, which is the area of London we now call City. There was Westminster, which is then, to some extent, a separate town. There was Deptford, where there was a lot of naval activity, which isn't that far from Greenwich Park. But Greenwich Park essentially was some way away from the centre of London, and therefore was an isolated position to have the observatory.
I'm just the reason why I actually wanted to ask it is because at that time, what were they thinking that the rate of growth would be, that the safe point to build an observatory? Because this does not seem that far away.
Yes. Well, they weren't thinking in these terms at all.
Okay.
Is the first question. Later in the 17th century, mathematicians began to look at mortality and life insurance and things like that. But up to this point, this hadn't really been considered. So that wasn't the kind of thing they looked at. And in fact, Greenwich remained an observatory up till the early 20th century. The problems then became street lighting, which of course hadn't been thought of in the 17th century. So it was all, there wasn't planning that far ahead.
Perfect. So Did the building of the observatory itself require some sort of special equipment from some other place, or was it just done here, everything?
Everything was done here.
Oh.
The instruments were made by Robert Hooke. He's now known as the great experimental scientist of the time. The first astronomer royal was John Flamsteed. He was paid £100 a year, which wasn't very much, and he had to provide his own instruments. He didn't like the instruments Hooke made for him. They fell out over it. Both Flamsteed and Hooke fell out with everybody they worked with, basically, so that wasn't surprising. And Flamsteed observed the positions of the stars. Remember, this is in the same century as the invention of a telescope. And Newton had greatly improved the telescope in the preceding few years. So Flamsteed really did have state-of-the-art equipment, and he was making the best star map ever made at the time.
So just to clarify, when the telescope was discovered, and what are we talking about, and when this observatory was built, just to make it a little clearer.
The telescope was invented beginning of the 17th century, about 1608. Galileo had an early one. So did the English astronomer and mathematician Thomas Harriot, who is a brilliant mathematician, not very well known. It was greatly improved by Newton, who had the idea of making a reflecting telescope in which the light basically is reflected down the tube, so you don't have to have such a long tube to get the same resolution. And there were developments in optics and so on, so these instruments really were coming to maturity just at this time. Okay. And Flamsteed, got incredibly accurate results for the time. Of course, he fell out with Newton over this because Newton wanted access to Flamsteed's data, and they had a previous disagreement about priority over an eclipse. And so, the story is that Newton got the Queen's husband, the husband of Queen Anne, to require Flamsteed to hand over his data so it could be published in a great book by the Royal Society. Newton was president of the Royal Society. He had the king on his side. Flamsteed reluctantly handed over his data. It was published, very badly edited, by Edmund Halley, who's otherwise a good guy, but he doesn't come out of that bit very well. Halley actually wrote an introduction accusing Flamsteed of laziness and incompetence, this in a published book. And when Queen Anne died and King George II came, Flamsteed quickly got... When Queen Anne died and was replaced by King George I, Flamsteed immediately got the new king on his side. He had all copies of the previous book recalled, and they were burnt in Greenwich Park. And Flamsteed worked on a better issue of his data, which was finally published after his death in the 1720s, and which is a beautiful book, very well produced.
Wow. Is this the data where he looked at the solar eclipses all around the world?
It was basically about positions of all stars. So at this point, the idea was that if people knew the positions of stars more accurately, they might be able to use them to calculate longitude. Everything the observatory is doing is based on finding longitude at sea, or trying to find a way to do that.
Brilliant. Okay, so then what is the next chapter in the story of observatory?
Well, the next chapter came when Flamsteed died, just before midnight on the 31st of December 1719. So he didn't see the new year. And his replacement was Edmund Halley, a very famous scientist of the time. You've heard of his comet. Yeah. He did all sorts of really good science in previous years. And Halley wanted to be Astronomer Royal because he wanted to win the generous £10,000 prize for finding a practical way of finding longitude at sea. Okay. Remember, that's 100 times a year's salary for the Astronomer Royal.
Yeah.
A lot of money.
Yeah.
And Halley wanted to do this by accurately recording the position of the moon over a 20-year cycle.
Wow.
He did this, but by the end of it, he was in his mid-80s. And remember, this is an elderly man staying up every night for 20 years to record the position of the moon. But the accuracy he got wasn't good enough for the method to work at the time.
Oof, that's a tough story.
Yes, but Halley is famous for all his other work
Indeed.
too. And I suppose the next step was the fifth astronomer, Neville Maskelyne. He was another, obviously, great astronomer, and he wanted to find longitude again by using the position of the moon and its distance from stars. And by this time, in the mid-18th century, the observations were good enough to do this, just about. And so Maskelyne solved the problem by publishing tables that mariners could take to sea, giving the predicted position of the moon over the next 2 or 3 years. And to do this, this involved a lot of computation, and this is where really numerical calculation becomes very important in Greenwich. Maskelyne set up the Nautical Almanac Office to calculate the positions of the stars and moon over a future period of time, some years, and this was life or death. If the data were wrong, if the calculations were wrong, ships would run aground. So Maskelyne invented all sorts of methods for checking results, which was revolutionary at the time, but it is very similar to what software engineers do now in the 21st century to ensure that safety-critical software works.
Yeah. So with the problem of these longitudes, there was a lot of ships who were crashing onto the shores or different kind of islands.
Yes.
Is there, if you can explain more that how important was it? I mean, that would be good just to give it a base.
Okay, well, the basic idea is, if you're at sea and you can't see any land, how do you know where you are? Your coordinates, in mathematical terms, are latitude and longitude.
Yeah.
Latitude is how far north or south you are, longitude how far east or west. Latitude is easy. There are various ways you can take it. Basically, the angle of the sun at noon or the angle to the pole star above the North Pole will give you that. Longitude is more difficult because basically, as the Earth rotates, everything changes, and the situation where you are now would be the same in a different longitude an hour before or an hour afterwards.
True.
So you can't use that to tell longitude. So there were two hopes. One was to use the distance between the moon and various stars, and this was what Maskelyne did, what Halley had failed to do. The other was to use time, because if you know what the time is at Greenwich, and you know what the time is where you are, you can calculate your longitude from that.
Okay.
Time where you are, is position of the sun at noon. When the sun is directly overhead, it is noon. The problem is knowing the time at Greenwich. If you take a clock with you, if that clock goes wrong, you're stuffed, basically. And so the alternative approach was to create a clock which would keep time accurate enough to be taken on a voyage lasting perhaps a couple of years and would still give you Greenwich time. And this was the second approach adopted by Harrison, who actually won the prize, the £10,000 for that approach.
Oh, so Greenwich is responsible for creating this time.
Yes. Well, we measure from Greenwich because that was decided in the 19th century because of Greenwich's history.
True. So the problem was about the accuracy of the instrument, which is a kind of a clock.
Yes. I mean, if you're thinking in the 17th century, clocks are pendulum clocks.
Yeah.
They're not going to work at sea in a storm. Robert Hooke and Christian Huygens invented the spring watch, which has more chance. But, you're travelling around the world, you're going through some high temperatures in places, metals expand and contract. How do you ensure your clock keeps perfect time when these dimensions are changing? And this was Harrison's genius. He invented lots of technology which allowed a clock, a chronometer, to keep accurate time at sea, in different temperatures, in storms, everything else. The only trouble with Harrison's invention was that it was very expensive. It cost more than a ship. So actually, although Harrison won the prize, it was Maskelyne and his mathematical tables that was the way people found their longitude at sea for a long period until the middle of the 19th century.
So how are the tables being? I mean, how do the tables work and the calculations?
Well, basically, they use Newton's mathematics of how planets and move around the Earth and bodies rotating in space, and just do lots and lots of mathematical calculations. They're very difficult. They're very long, tedious calculations, and they have to be done to great accuracy. So what Maskelyne did, he didn't do it himself. He employed people to do the calculations for him. And he employed, for every calculation, there were two people doing it. One was called the computer, and the other the anti-computer. That's the word in these days. And a third person, the comparer, compared the answers. If they were the same, they passed. If they were different, then they had to be redone.
Oh, okay.
And Maskelyne expected there to be errors. In fact, the story is that when two of his computers agreed too closely, he had them both sacked because he thought they were fixing the results. They were corresponding with each other. And thereafter, he took care to make sure that the computer and the anti-computer didn't know who each other were and were in different parts of the country.
Okay, so that's smart. He's actually accounting for a human bias or issues which could come
Absolutely.
up.
I mean, Maskelyne was an incredibly modern pioneer of computation. He doesn't get the credit he deserves. And one thing I hope this book will do, thanks to Mary Crokin's article about him, is give him that recognition.
Okay. Yeah. Is there any other more story about him before we move on?
Well, Maskelyne has had a bad press because he is seen in a famous book of the 1980s, David Sobel's Longitude, as the villain who conspired to stop Harrison getting the money. And that's a rather... It's a good story, but that's not an accurate reflection, in my opinion, of what actually happened.
Well, now he got some good press. Finally, he made it.
Hopefully, yes.
So, actually, the work itself about the clocks and the time and the tables, does that has any effect on the theory of time or any other Newtonian or theories itself? Or is it just... Yeah.
Well, yes. I mean, the big breakthrough in 20th century physics, of course, was Einstein's theory of general relativity. And this was a controversial theory when Einstein put it forward in the 1916 or so. But the astronomer royal at the time, Dyson, had the idea you could check this out in a solar eclipse. And there was a solar eclipse in 1919.
And was the Dyson working in the Royal Observatory
Yes,
here in Greenwich? Okay.
He was the astronomer royal up there.
Yeah.
And he had this idea, and so this was a great feat of organisation because the First World War had only just finished, but various astronomers from all around the world were sent to key places around the globe where they could observe the eclipse. So there was one group in Brazil, another in India, so on, and they were lucky. The weather was fine for some of them, so they could actually see it because clouds would have ruined it. And the results confirmed Einstein's theory.
Wow.
And Arthur Eddington gets associated with this. He was one of the observers. The story is when he came back from his trip, one of the journalists asked him, Mr. Eddington, I'm told that Einstein's theory is so complicated that only 3 people in the world understand it. Is that true? And Eddington paused for a bit, and the reporter repeated the question, and Eddington said, well, there's me, and there's Einstein, but I don't know who the third one is. The story is probably not true, of course.
That is funny. Yes.
I
was thinking he would be saying something really humbling, but...
Yes. No, I don't think he was a very humble man.
Okay. So the general relativity is actually the contribution here in Royal Observatory is one of the very crucial ones because there were four different observatories which actually tested the relativity through eclipse.
Yes, I don't think Greenwich actually took observations because it wasn't in the right place. But it was certainly Dyson who had the idea and who did a lot of the organisation which made it possible.
Okay, so is general relativity complicated to understand?
Yes, I think is the answer. It's counterintuitive. Basically, what it, my understanding, and I'm not an expert, is that it regards time and space as intricately connected and not flat in the sense that the structure of space-time is curved. So it's like the surface of a globe is curved. If you measure the angles in a triangle on the surface of a sphere, they don't add up 180 degrees.
Yeah.
And this is because it's the surface of a sphere, but it turns out, according to general relativity, that in fact the whole of space-time is curved. and Euclid's geometry does not apply to the universe in which we live.
So,
which is
and it's curved because there is mass inside the universe, and that actually curves
yes,
the curvature.
Yes, I mean gravity is actually a curvature of space caused by mass.
Yeah, and. Is there any new news? I mean, if you're here, I would ask about the gravitational waves which they detected in 2015, if I'm correct, 2016 maybe. Is there any new news, or is it something completely different to...
It's way outside my area of expertise. It's one of these things that I think it's very hard to understand unless you're really in the field.
Okay.
I know there's a lot of exciting work in quantum gravity.
Okay.
But, I mean, and of course quantum theory has interacts with relativity in ways we don't fully understand.
True. So there were some I think some attacks which I was reading in the book on observatory from anarchists. I mean, that was a very odd kind of an episode.
Yes, it was late 19th century. There was an anarchist scare around the world at the time, and one afternoon, a young Frenchman living in London came up to the observatory with a bomb, and we don't quite know what happened. The bomb exploded, the anarchist was killed, and a brick in the observatory was damaged. We really don't know very much about it. Joseph Conrad wrote a novel called The Secret Agent, in which a young man attacks the observatory, set up by the police as a... sorry, I can't think of the word. Set up by the police as an adjunct provocateur.
Oh, okay, yeah,
yeah,
of course.
Yes. Conrad claimed to special information about Greenwich. It's plausible that this was the case, that we just don't know why this young man attacked the observatory in this way. He killed himself, so we don't know any more about it. There was a major panic, of course, at the time. It's a very murky episode, basically. Yeah. But it was, one of the first suicide bombing attacks in the world.
Oh, wow. That's so strange.
Whether the bomber intended to kill himself, we don't know.
That's true. That's all, unfortunately.
Yes.
Many of the stories which I've heard after these kind of attacks does tend to have a little bit of humor, because you never know, was it like an accident or they were really trying to do what it is. True.
Yes, I mean, it's not clear why anarchists would have attacked the observatory at all.
Yeah.
It's all very strange.
So there's also, I think I read about one of the first women who were allowed to become the members.
Yes, well, one of the sad things about this book is that almost everybody discussing it is male, because that was the world until relatively recently. But, for example, there was a distinguished astronomer, Annie Scott Russell, who married Walter Maunder, another astronomer at the observatory, and she was employed at the observatory to do calculations. When she married, of course, she had to resign, because that was the way these days. But she came back during the First World War when they needed helpers, and was with her husband. Her husband supported the admission of women into the Royal Astronomical Society, for example. She was, I think, one of the first fellows of the Royal Astronomical Society. She did very distinguished work, but it's hard to separate what she did and what her husband did, because a lot of her work was published in her husband's name, as was normal in these times, unfortunately.
Yeah, because that would get you into the publishing book and would allow you to...
Yes, I mean, this wasn't her husband stealing her work. It was actually just the way it was published.
True.
But it is, there are other women in the story. One of Maskelyne's computers was a woman.
Okay.
But we only know that because basically her husband was a computer. When he died, she took it over from him. And it's pretty clear, in fact, she had been doing it all along. But her husband had been the contact for Maskelyne because married women didn't work.
Yeah. This is actually a fascinating side story around a book where you can somehow analyze or see the shadow of our society, how it was working around these kind of cultural or gender issues.
Absolutely. I mean, during the Second World War, for example, the buildings which are now the Old Royal Naval College were used by the military, and I met a young man, well, an old man now, who had been a young man at the time, who had been based in King Charles Court, and part of his job was, anytime there's a bomb alert, he had to run down the basement and pull the curtains to block off the view of the latrines, so that the female workers in the building didn't have to see them as they went to the air raid shelter.
Wow.
But when the British Mathematical Colloquium was held at the Royal Naval College in the 1950s, women mathematicians came. There were 2 women mathematicians came to this major conference, and this caused real logistic problems because women weren't allowed on the site. So they had to be given naval ranks in order to attend the conference.
Oh, okay. So that was more like a ritualistic way of...
Yes, I mean, it was a practical way of solving the problem, and it worked, basically. But yes, I mean, one of the nice things about working at Greenwich today is the huge diversity we have among staff and students at the university, and that wasn't the case in most of the history of Greenwich.
True. I mean, what truly makes me a bit sad is that most of the time we do hear that a lot of males are mathematicians, but as the history is unraveling itself, you realize that how many mathematicians were there outside of just one gender. So that
Absolutely.
actually is a story which I think would continue unravel for sure, but this would be such an interesting point finally we have a whole list of heroes who are mathematicians, and then the lot of young girls who think and who have been told that, oh yeah, maths is not some field which you wanna go, and finally they would have a clear path.
Absolutely. I mean, one of the nice things about Greenwich is that over the last few years, the gender ratio amongst mathematics students has been about 50-50.
Oh, wow.
And that's good, and it's improving nationally, but I think, nationally we are amongst leaders on that.
Yeah.
It's very helpful to have people like Hannah Fry around. I mean, Hannah Fry writes popular maths books and has done TV programmes. She actually lives in Greenwich. But, people like her are making a huge impact. But it's not just gender. Last week, Greenwich gave an honorary degree to Dr. Naira Chamberlain, who is the next president of the Institute of Mathematics and its Applications. He's a black mathematician. He's the first black mathematician to be in Who's Who.
Wow.
And when he was a child, he was told by his teachers he couldn't be a mathematician, he should aspire to be a boxer instead.
Of course.
Okay, that was 30 years ago, but 5 years ago his son was told exactly the same. And so there are still battles to be fought and won there, but it's good that there's now so much awareness of these issues.
I mean, yeah, that kind of I'm not sure if that's why I was asking about this, that it was pretty much determined about anything in the society, maths or engineering, which is a little bit somehow perceived higher status or more intelligent or difficult job, to be associated with anyone who is in power. It's like, this is the thing could only be done by these kind of people.
Yes.
But yeah, as there are many stories in in the books, and as any story as you are mentioning.
Well, one of my heroes is a mathematician called Charles Godfrey, who was appointed Professor of Mathematics at the Royal Naval College in 1921, and sadly he died not long afterwards. But he's remembered as a pioneer of maths education. He was one of the people who modernised the mathematics curriculum at the beginning of the 20th century, and he was one of the authors of an influential letter signed by 22 mathematicians and known as the Letter of 23 Mathematicians for some strange reason, published by Nature, calling for changes in mathematics education. And he was a great pioneer, and I have one of his books. And the thing that strikes me opening it now is that it is assumed the reader is a boy. All the references are to boys. Boys will find this easy, boys will find this harder, whatever. And, it makes one aware how far one has come, that liberal people could take that view back in the 1920s.
Of course. And another part which is a little bit strange is the problem of people, limiting someone's entry to certain fields, or
Yes.
even into certain kind of self-respecting way of just realizing that someone has a potential and they can do it.
Yes.
They themselves have used math to actually block people who could help math by developing certain kind of narratives or test in certain times to somehow not allow a lot of people. I think more like it's a general problem also overall, as you're saying, everywhere, that how 100 years ago liberal people would take certain kind of views. Of course, I mean, I'm sure that at some point that view was completely normal, but I do feel that this problem is more general, but
Right.
math it's very prominent when it comes to mathematics.
Yes, well, mathematics tends to have hard and fast answers, and that makes it easy to use as tests. And it's interesting because back in the 19th century, when the Royal Naval College was set up at Greenwich, it was seen as a sort of naval university, and all lieutenants had to go through a training at Greenwich, and they had to learn mathematics. And there are letters from the Admiralty in which people are saying that there's a real problem, because very good seamen, people who'd be perfect at sea, were failing in maths. And they didn't want to lose good sailors just because they couldn't do maths, which was typically of the time, mathematics that was not necessarily very practical. And we get similar things here with, GCSE maths is a gatekeeper for getting into university. Should it be?
I mean, that's another thing. I mean, this is happening right now. I mean, what is your view around it? I mean, have you thought about it, that why now math, of course, has become something so authoritative, you can say, because it has proved that how useful it is. Although that now taken away from the field itself and then used in a system to, as you're saying, being a gatekeeper. I mean,
Yes.
What are your thoughts about it?
Well, obviously, anybody working in maths thinks a lot about this. For some subjects, like engineering, for example, the whole subject is based in mathematics, and basic mathematical training, I think, is required. I think the trouble is that as soon as you start having examinations, first of all, not everybody is equally good at exams, and you can have people who are perfectly good mathematicians who can't do well in exams. But also, you tend to assess what is easy to examine rather than what really matters. And the current GCSE, I'm not convinced it's a good measure of mathematical knowledge, ability, the ability to apply mathematics. Obviously, to do a maths degree, you'd want to have done the kind of maths you do at A level. But to do a degree in computing, for example, does maths GCSE help you? Maths helps you, but I'm not convinced GCSE maths is the right measure of whether somebody is able to do a degree in, say, computing or history or whatever other subject you think of.
True.
So I think there are problems. I mean, mathematics is important. The more people study mathematics, the better. But it becomes difficult when you start saying people must have passed maths to do the next step.
True. That's a very interesting point, as if it's an other angle of a problem. That first, most of the races or gender, let's say, would be blocked to do math, and then the other side of the problem is that everyone has to prove their worth by actually doing some sort of a math, which is not, as you're saying, it might not be designed how helpful it is, but it would be designed for more of a mass testing or on a mass scale education kind of any other thing which has been more convenient on a grand industrial level, let's say.
Yes, I think that's very much the case. I mean, one problem with maths education is the quality of teachers is very important. And one of the reasons I think GCSE maths is not a good measure of somebody's ability is simply the quality of teaching varies so enormously. There's a huge shortage of maths teachers. And one of the things I'm very proud of from my time at Greenwich is that it's now considered normal, in fact desirable, for many students to become maths teachers. That wasn't happening 30 years ago in the maths world. Maths graduates generally were not going to teaching. But now, 20% of our graduates each year train as maths teachers, and they're making a real difference to schools in South London and beyond. And one of the things we've introduced is a scheme where final year students work in schools 1 day a week. It's called the Undergraduate Ambassador Scheme. It was invented by and funded initially by the writer Simon Singh. And we are sending 20 students a year into schools, and I think that's enormous benefits to the students and to the schools and to the school students.
So a lot of this, which we mentioned in the start of this podcast about why Greenwich Mathematics Department is actually really prestigious. I mean, this has also to do with the observatory being here and a long list of such tradition towards understanding maths and finding new discoveries in math.
I think there's a certain amount of randomness in this. I mean, there's no real connection between the observatory and the university, or between the Royal Naval College and the university. However, mathematicians working at all three institutions have been very interested in education. The Royal Naval College had a number of professors who were heavily involved in the mathematical education world in the late 19th, 20th centuries. They were several presidents of the Mathematical Association. The Astronomers Royal have always been interested in popularising the subject. And so there is a tradition. I think it's a bit of a fluke that it's continued. I mean, it's not because the institutions are connected, but it is, I think, one of the very nice things about Greenwich is that not only is there a history of mathematics and computation, but there's also a history of support for mathematics education and maths education reform.
Okay, so we haven't finished the story, of the observatory. So what happened in the end? How did it came to...
Right. Well, in the 19th century, the astronomer of much of the 19th century was George Burdell Airy, who is a very competent mathematician who is known in history partly for his attacks on Charles Babbage's calculating machines, which are now seen as a forerunner of the computer. And Airy was essentially the civil servant who recommended that Babbage's government funding be stopped. And there's a chapter in the book by Doran Swade which gives Airy's, it gives the story, but it makes it clear that Airy was not being unreasonable in his views at the time. But Airy is remembered for things which in retrospect he got wrong. For example, he didn't use the observatory's telescope to look for the planet Neptune when it was suggested he might by John Couch Adams, the English astronomer. As a result, the French found the planet before the British did, and Airy was blamed for that. But all his decisions at the time were perfectly justifiable. He was just unlucky the way it worked out. So he was unlucky. But basically, after that, the railway came to Greenwich, and that caused changes in magnetism. And London became brighter, the skies became brighter, observing Greenwich became impossible. The observatory moved first to Herstmonceux in Sussex, and essentially later to Cambridge, but now no longer exists as an institution.
Okay, so it moved somewhere?
They moved the telescopes to Herstmonceux in Sussex round about the time of the Second World War.
Okay. So visitors can still go and...
It's now a museum, essentially.
Okay.
There are excellent exhibits, and we have a chapter in the book by Richard Dunn about the exhibits in the National Maritime Museum, the mathematical instruments there. The observatory itself, you can see the telescopes, you can see the octagon room designed much as Christopher Wren designed it in the 1670s. You can see Harrison's clocks in the observatory. It's a wonderful museum, but it's no longer a working scientific institution.
Okay. I thought for some reason that they open up for observation, that there is some sort of a telescope still there, but not at all.
There are telescopes, but they're historic telescopes. They're not, observations now tend to take place in Hawaii and places like that. astronomers have a nice life.
Yeah. Oh wow. So where are most of the actual observatories now? That would be interesting to find out.
Yes, I think Hawaii, generally islands away from big cities, and of course the big telescope now is the Hubble telescope out in space.
Yes, yes. Oh. I wish would have, somehow figured it out earlier that all the observatories would be somewhere in Antarctica, or is there any observatory in Antarctica?
I don't know.
No, okay.
Answer.
Well, I mean, I'm thinking maybe because I mean
Yes.
that's actually pretty clean.
Yeah.
There isn't anyone over there. That's
Yes.
where my
Yes.
spot is generally. That's where I wanna work for most of my life.
Okay. Well, I know a mathematician who spent a few years in Antarctica.
What was going on?
I don't know exactly. He was a statistician, but I don't know exactly what he was
Okay.
doing.
Yeah, that's brilliant. All these stories. Okay, so any other favorite of your stories?
I think another favourite, I think I should possibly say that the Royal Naval College came to Greenwich in 1873, and several famous mathematicians worked there, including William Burnside, a pioneer of group theory, Louis Milne Thomson, a fluid dynamicist, and other big names. My favourite from the Royal Naval College is John Knox Lawson. He was a young, he studied mathematics at Cambridge. He got a first-class degree. He was called a Wrangler. Normally, that would ensure you get a fellowship in your college, but he was unlucky because there were 4 other Wranglers above him from the same college. So he couldn't do that, so he joined the Navy, went to sea, became a mathematical teacher at the Royal Naval College, then at Portsmouth. When it moved to Greenwich, he moved with it, and he taught mathematics at Greenwich for 10 years or so. Towards the end of that time, he developed an interest in naval history, so he gave a few extra lectures on naval history, for which he was paid, I think, an extra £30 a year. His salary was about £500, I think, at the time, so it's that sort of a small bonus, not a huge amount. And in 1885, the Navy decided to abolish most of its instructor posts. Basically, this is a consequence of the concern about the level of maths required by naval people. And Lawton lost his job. He was given the choice of going back to sea on half pay or retiring. And at this point, he's 55. He's been teaching mathematics for many years. He chose to retire. But he then applied for the job of Professor of Modern History at King's College London. And he got it. And this seems today quite astonishing. How would a retired mathematician get a job as Professor of History? But he got a job. He's now known as the founder of modern naval history. He was a very important historian. He had a huge influence on his successors. He was knighted for it. And all because the university decided the Royal Naval College decided they didn't want him to teach maths anymore.
Wow.
So
some sort of contribution at least,
Yes. But it just shows how much luck there is involved in almost any career.
True.
Basically.
So is there a story in transitioning of Royal Naval College into University of Greenwich, or is...
Yes, well, the Royal Naval College, basically, these buildings, now called the Old Royal Naval College, were built as a hospital for retired sailors in the 1690s. They worked in that role for 150 years. By the middle of the 19th century, times had changed. Retired sailors no longer wanted to live with their shipmates, they wanted to live with their families. And the Navy was now much smaller. So the buildings were falling into disuse. And William Gladstone, the MP for Greenwich, trying to get jobs for his constituency, got the Royal Naval College moved to Greenwich. I think not entirely with the full support of the Royal Navy, who didn't feel Greenwich was the best place for it.
Mm-hmm.
So the Royal Naval College came here, but it wasn't the best place for it. It was too close. It was too far from the sea and too close to all the pubs in London, allegedly. So eventually, things got smaller. They moved many of the training things elsewhere. The last thing to stay was the nuclear reactor, what is now King William Court, which was used to train submarine seamen.
Wait, where?
King William Court, where
Okay.
the ground floor lecture theatre now is.
Yes. Okay.
And so
Okay.
and it was moved out before the university moved in.
Of course. I mean,
As
we
in-
should still not go there.
Well, that's okay. Greenwich was a nuclear-free zone at the time,
Oh,
allegedly.
wow.
But so basically, the buildings again, had no function, and the Prime Minister, a government of the day, had the plan of selling them to a private company to run as a hotel or similar, and that was the plan. However, just before this happened, Mrs. Thatcher had abolished the Greater London Council, and their headquarters, County Hall, had been sold off to a Japanese company to run a hotel. They made a higher offer than the London School of Economics, which was also interested. And this got some criticism in the press for the government favouring a private hotel company over an education establishment. So when it came to getting rid of the Royal Naval College buildings in Greenwich, because of that previous bad publicity, the government chose instead that they should be given for educational purposes, and the University of Greenwich was successful in getting a lease on them,
Yeah.
which was just a case of being in the right place at the right time.
Wow.
Basically.
Perfect. That
Yeah.
is a beautiful story.
Yeah.
Anything else would you like to add?
I think we've covered quite a lot.
Yeah.
I think there's a long history of Greenwich. It's a very rich history,
Yes.
and I think I'm very proud that the university is now part of it.
Brilliant. Same here. I love walking around these buildings. I always, when I'm here, my feeling is of Voyage and discoveries, and
That's very appropriate.
that's actually why now I can see it from the history as you are telling me. Yeah, brilliant. Thank you, Tony. Thank you for
You're
doing
welcome.
it.
Thank you.
Brilliant. Bye, everyone.